Jessie Packard, and this is my partner, Yuli, and we're going to be lesson 3, question 1. And that says, define phylogeny and explain what we can learn from phylogenetic trees.
Awesome. So from what I got from it, phylogeny is like a construction of these kind of like family trees, and that demonstrates the relationship between species, and it can show their common ancestry. And we can use these trees to show the different modifications that occur over time, because as you move from left to right, we see that there's a change in time. And so we can see how these different species are changing and having modifications with time. And I think one of the main things we can learn is how the different relationships exist between species and their history. And so I really like using the screen share tool because it just helps people. And so I just have kind of like a basic outline of phylogenetic tree. And so we see kind of these branches that are coming off of the tree. And so as we move from left to right, we know that there's a change in time. And then as we reach these endpoints of the branches, these are usually species that are existing. They're extant species, and as we move backwards, these are more likely to be extinct. And so here we have a common ancestor of the species that branch off of it this way and this way. And so we can use phylogenetic trees to kind of create a nice organized way of viewing how species are connected to each other. And I think that's just a really awesome way, awesome and simple way of doing that. So is there anything that you'd add?
The only thing I was thinking of is something that the trees can be really, really simple, but I love how some of them you can go back and see characteristics that those species have in common, and then you can see how those characteristics have changed from their ancestral form and to form like the species that we see. So it's kind of cool to see the different characteristics that they share, but then how they branch off from those. So
Yeah, definitely. Definitely. And I didn't have a good example in that tree, but it'll show like what makes, in some phylogenetic trees, what made that species different, whether it was like a change to the color of their tail, or it was this, this different phenotypic change that happened. And so you can actually look at it and say, oh, this is what was different, physically, and see like the cool changes that happen over time. So I definitely agree.
yeah. Cool, I think that was it.
All right, well, I'll get this posted, and I think we're all good. All right, perfect.